The menstrual cycle refers to the regular changes in the activity of the ovaries and the endometrium that make reproduction possible. The endometrium is the layer of tissue lining the inside of the uterus. This lining consists of a functional layer, which is subject to hormonal changes and is shed during menstruation, and a thin basal layer, which feeds the overlying functional layer. The menstrual cycle actually consists of two interconnected and synchronized processes: the ovarian cycle, which centers on the development of the ovarian follicles and ovulation, and the uterine or endometrial cycle, which centers on the way in which the functional endometrium thickens and sheds in response to ovarian activity. Menarche, which refers to the onset of the first menstrual period, usually occurs during early adolescence as part of puberty. Following menarche, the menstrual cycle recurs on a monthly basis, pausing only during pregnancy until a person reaches menopause, when her ovarian function declines and she stops having menstrual periods. The monthly menstrual cycle can vary in duration from 20 to 35 days, with an average of 28 days. Each menstrual cycle begins on the first day of menstruation, and this is usually referred to as day 1 of the cycle. Ovulation, or the release of the oocyte from the ovary, usually occurs 14 days before the first day of menstruation. In other words, 14 days before the next cycle begins. So for an average 28-day menstrual cycle, this means that there are usually 14 days leading up to ovulation, in other words, the pre-ovulatory phase, and 14 days following ovulation, i.e. the post-ovulatory phase. During these two phases, the ovaries and the endometrium each undergo their own set of changes, which are separate but related. For the ovary, the 2 weeks leading up to ovulation is called the ovarian follicular phase, and this corresponds to the menstrual and proliferative phases of the endometrium. Similarly, the 2 weeks following ovulation is referred to as the ovarian luteal phase, which also corresponds to the secretory phase of the endometrium. So let's first focus on the pre-ovulatory period, starting with the ovarian follicular phase. This phase starts on the first day of menstruation and represents weeks 1 and 2 of a 4-week cycle. The whole menstrual cycle is controlled by the hypothalamus and the pituitary gland, which are like the masterminds of reproduction. The hypothalamus is a part of the brain that secretes gonadotropin-releasing hormone, or GnRH, which causes the nearby anterior pituitary gland to release follicle-stimulating hormone, or FSH, and luteinizing hormone, or LH. Before puberty, gonadotropin-releasing hormone is released at a steady rate. But once puberty hits, gonadotropin-releasing hormone is released in pulses, sometimes more and sometimes less. The frequency and magnitude of the gonadotropin-releasing hormone pulses determine how much follicle-stimulating hormone and luteinizing hormone will be produced by the pituitary. These pituitary hormones control the maturation of the ovarian follicles, each of which is initially made up of an immature sex cell, or primary oocyte, surrounded by layers of theca and granulosa cells, the hormone-secreting cells of the ovary. Over the course of the follicular phase, these oocyte-containing groups of cells, or follicles, grow and compete for a chance at ovulation. During the first 10 days, theca cells develop receptors and bind luteinizing hormone, and in response, secrete large amounts of the hormone androstenedione, an androgen hormone. Similarly, granulosa cells develop receptors and bind follicle-stimulating hormone, and in response, produce the enzyme aromatase. Aromatase converts androstenedione from the theca cells into 17-beta-estradiol, which is a member of the estrogen family. During days 10 through 14 of this phase, granulosa cells also begin to develop luteinizing hormone receptors, in addition to the follicle-stimulating hormone receptors they already have. As the follicles grow and estrogen is released into the bloodstream, increased estrogen levels act as a negative feedback signal, telling the pituitary to secrete less follicle-stimulating hormone. As a result of decreased follicle-stimulating hormone production, some of the developing follicles in the ovary will stop growing, regress, and die off. The follicle that has the most follicle-stimulating hormone receptors, however, will continue to grow, becoming the dominant follicle that will eventually undergo ovulation. This dominant follicle continues to secrete estrogen, and the rising estrogen levels make the pituitary more responsive to the pulsatile action of gonadotropin-releasing hormone from the hypothalamus. As blood estrogen levels start to steadily climb higher and higher, the estrogen from the dominant follicle now becomes a positive feedback signal. That is, it makes the pituitary secrete a whole lot of follicle-stimulating hormone and luteinizing hormone in response to gonadotropin-releasing hormone. This surge of follicle-stimulating hormone and luteinizing hormone usually happens a day or two before ovulation and is responsible for stimulating the rupture of the ovarian follicle and the release of the oocyte. You can think of it this way. For most of the follicular phase, the pituitary saves its energy. Then when it senses that the dominant follicle is ready for release, the pituitary uses all its energy to secrete enough follicle-stimulating hormone and luteinizing hormone to induce ovulation. While the ovary is busy preparing an egg for ovulation, the uterus, meanwhile, is preparing the endometrium for implantation and maintenance of pregnancy. This process begins with the menstrual phase, which is when the old endometrial lining, or functional layer, from the previous cycle is shed and eliminated through the vagina, producing the bleeding pattern known as the menstrual period. The menstrual phase lasts an average of 5 days and is followed by the proliferative phase, during which high estrogen levels stimulate thickening of the endometrium, growth of the endometrial glands, and emergence of spiral arteries from the basal layer to feed the functional endometrium. Rising estrogen levels also help change the consistency of the cervical mucus, making it more hospitable to incoming sperm. The combined effects of this spike in estrogen on the uterus and cervix help to optimize the chance of fertilization, which is highest between day 11 and day 15 of an average 28-day cycle. Following ovulation, the remnant of the ovarian follicle becomes the corpus luteum, which is made up of luteinized theca and granulosa cells, meaning that these cells have been exposed to the high luteinizing hormone levels that occurred just before ovulation. Luteinized theca cells keep secreting androstenedione, and the luteinized granulosa cells keep converting it to 17-beta-estradiol, as before. However, luteinized granulosa cells also respond to the low luteinizing hormone concentrations that are present after ovulation by increasing the activity of cholesterol side chain cleavage enzyme, or P450-SCC for short. This enzyme converts more cholesterol to pregnenolone, a progesterone precursor. So luteinized granulosa cells secrete more progesterone than estrogen during the luteal phase. Progesterone acts as a negative feedback signal on the pituitary, decreasing release of follicle-stimulating hormone and luteinizing hormone. At the same time, luteinized granulosa cells begin secreting inhibin, which similarly inhibits the pituitary gland from making follicle-stimulating hormone. Both of these processes result in a decline in estrogen levels, meaning that progesterone becomes the dominant hormone present during this phase of the cycle. Together with a decreased level of estrogen, the rising progesterone level signals that ovulation has occurred and helps make the endometrium receptive to the implantation of a fertilized gamete. Under the influence of progesterone, the uterus enters into the secretory phase of the endometrial cycle. During this time, spiral arteries continue to grow and the uterine glands begin to secrete more mucus. After day 15 of the cycle, the optimal window for fertilization begins to close. The cervical mucus starts to thicken and becomes less hospitable to the sperm. Over time, the corpus luteum gradually degenerates into the non-functional corpus albicans. The corpus albicans doesn't make hormones, so estrogen and progesterone levels slowly decrease. When progesterone reaches its lowest level, the spiral arteries collapse, and the functional layer of the endometrium prepares to shed through menstruation. This shedding marks the beginning of a new menstrual cycle and another opportunity for fertilization. Alright, so as a quick recap, the menstrual cycle begins on the first day of menstruation. For an average 28-day menstrual cycle, the changes which occur in the ovary during the first 14 days are called the follicular phase. Ovulation usually occurs at day 14, as a result of the estrogen-induced surge in luteinizing hormone. The last 14 days of the cycle are the luteal phase, during which progesterone becomes the dominant hormone. While the length of the follicular phase can vary, the luteal phase almost always precedes the onset of menses by 14 days. The uterus also goes through its own set of changes. During the first 14 days of the cycle, the endometrium goes through the menstrual phase and the proliferative phase. During the last 14 days, it goes through the secretory phase.